and got it, and share my screen. And let's go over here the quiz problems. So again, I'm trusting you all to grade your quizzes honestly and fairly because doing that is beneficial for your education to be able to see directly what you got wrong and why right now. So please don't take advantage of that. Problem one up here, our longest problem of them all. I have again up here on my screen, the top screen is the top of the screen is the quiz, and then the bottom is a terminal window opened on the Lambda server. I'll use Control R, type in this long CD command, get my cat logs. EOF like this. Everybody should be double checking that I'm not making any typos here. Info blah. There's a typo. Info blah. Warning blah blah blah. Info. I'm having a bad day typing. Blah. EOF like that. That should be our logs file, correct? And then coming down here onto line 8 of the quiz, let's cat output into quiz.sh more. Here document input redirection. And now this problem, the only difference between this problem and one of your practice quiz problems is that I added this line 9 to 10 here with a grep of EOF before all of this other stuff. So if cat logs pipe grep EOF output redirection /dev /null, then 1, 2, 3, 4 touch EOF, else if cat logs pipe grep error /dev /null, then touch error like that. If cat logs pipe grep warning /dev /null, then touch warning. Lots of things to type here. Elif cat logs pipe grep info into /dev. Oh, thank you. Not ogs, logs. /dev /null. By the way, so what I did there to go back a little bit faster, instead of using the left and right keys like a sucker, I press the control key and then the left and right keys, and I can jump by words instead of by individual characters. Again, that's control for everybody, not command for people on Macs. /dev /null, then 1, 2, 3, 4 touch info, and finally phi and EOF. And hopefully there's no typos there. And now we're going to run this quiz.sh file and see what happens. sh quiz.sh like this. No error message. And the idea, so big picture idea of what this problem was trying to test here is that all of these if-else statements going through the different logs file looking for different strings. And does this first line up here, do we capture this EOF up here? It might look like, because there's an EOF here in this here document, that we might be putting that into logs, but if we do just cat logs like this, then we see there is no EOF line over here. This is just like the end quotation mark, and so it's not actually in that file. And so line 9 here, this condition will not evaluate to true. We shouldn't create this EOF file. We should go down here to line 11 and then keep going like the practice problem in your practice handouts, and the warning over here will evaluate to true because we have a warning inside of here, and we'll see that warning file up here. I'll type ls, and there we go. 3 files, logs, quiz.sh, and warning. You have to have all 3 of those files present in your output to get credit for the problem. I don't care about the order. I don't care if you put it all in one line or 3 separate lines. But if you have any file in addition to these 3 files, or you do not have one of these 3 files, then you will not get credit for the problem. No partial credit. It's either a 0 or a 1. Any questions on this? Yes, Evan. Question is grep case sensitive? The answer is, by default, with no arguments to grep, it is case sensitive. So here, if so warning and warning match each other exactly as all uppercase. Regular expressions in general are by default case sensitive. If you want to make grep non-case sensitive, then the thing to do is to, in general, if ever you want to, or you feel like a program has something sort of related to that program, then it probably should be able to do the man page for the program, man grep. Man stands for manual, not like man like person. So the manual for grep, you type man grep like this and hit enter. Here's all the different options. You can scroll up and down, or you can use in any terminal application the slash key searches. General, any open source program will have the slash key being searching. So like on Firefox, for example, if you wanted to search a web page, instead of pressing Control F like a sucker, 2 keystrokes very far away from each other, you can just press slash and search the web page. So slash, and then I don't know, something like case, and we can get -I over here to get this ignore case option, Q to leave this environment, and so grep -I, according to the man page, would make it case insensitive. Good question, not directly related to the answer of the problem, but feel free on any of these quiz problems to ask, as we're going over them, to ask problems related to them that you think will help your understanding like this, or help you in future problem sets. Any other questions? Yes, Oliver.
I noticed that the call for the second year document didn't have single quotes around it. Can you remind us what the significance of not having quotes?
So the question is here on line 8 at the end of EOF over here, there is no quotation marks around this EOF. It's just a plain EOF. And the answer is that when you don't have quotation marks around your here document string EOF, then this will be treated like a string in double quotation marks, which means that any $signs will result in expansion happening. In this case, there are no $signs anywhere in the here document text. And so whether you have quotation marks or not, you would get the exact same here document, the exact same document created in quiz.sh. Good questions. Problem number 2. A nice, much shorter problem. Down here, I'll press Control-C. Anytime you're on a command line that you've started typing things in and you want to just ignore what you've typed in, you could press backspace a whole bunch of times, or you could press Control-C and just get yourself a fresh new line easier that way. Press Control-R, get my CD command like this, type foo equals hola like that, and square bracket. Remember that you have to have a space after the square bracket or you will get a syntax error. $foo equals hello like this. In general, you want spaces between everything in your square bracket expressions in order for them to be interpreted correctly. Or echo $foo like that, output redirection false, hit enter. And recall again that the output redirection, anytime you have any sort of redirection operations here, whether it's the append redirection, the single greater than output redirection, the input redirection with here documents, the pipe, any of these sorts of operations that control the input or output to a program, those bind. We say they bind, which means they attach to this most close program right here, and don't by default travel over these or signs or and signs. So this false will only get created. This output redirection will only get interpreted or run if this echo program ends up getting run. And due to the short circuiting, this echo program will only get run if this thing over here evaluates to false. So let's type ls now, and we can see that the file false was created. The answer here is false because this thing over here evaluated to false, and so this thing over here was in fact run. Any questions on problem number 2? Problem number 3. Let's reset my screen. Control-R, CD, foo equals solve cat quiz.sh here document foo equals hello world bar equals salve mundi if false or $bar mundi equals salve mundi and true. I don't think I have typos, but nobody's shouting out, so I'll hit enter. Touch. There we go. Touch if else touch. Let's add spaces just to make it look nice. And like that. And line 11. EOF. Okay, so we've created our quiz.sh file inside of it. And a couple things being tested here. The first one is without these quotation marks. Again, like we talked about a few minutes ago, this EOF, this here document, will be treated as if it was in double quotation marks. And so the $sign substitution will happen at the moment that this here document is created. We do have a $sign inside of here, and so this will be expanded at the moment of here document creation, and not at the moment when the quiz.sh is ran. We can verify that again with the cat command. Again, cat is idempotent. It's not going to modify the file system in any way, so I can always debug things. I can always inspect what's going on using the cat command without modifying the output of my quiz problems here. And so I'll do cat quiz.sh like this, inspect the file before I actually run it, cat quiz.sh. And now we can see that there are, in fact, no $signs inside of here because they all got expanded. In this case, you can see that the bar variable did not exist at all, and so no expansion happened, or by default, the variables have they're empty. There's no error messages in the shell when you use a variable that you haven't defined. It's just sort of defaulted to being empty. And so this thing over here expands, and we get this space mundi right here. That is not equal to this over here, so when we run this expression here will evaluate to false. Let's do run ls again. So ls, another idempotent operation. We can see that we have this quiz.sh file that we created in the here document expression. And now I can do sh quiz.sh line 12 in the quiz, hit enter, and type ls again to get the final result. And we can see that it is else and quiz.sh. So again, for full credit, you have to have both of these file names in your output. I don't care about the order of the file names, but you must have exactly those two files and no other files. Any other questions on this problem? Okay, problem number 4. Down here, reset. Control R, CD, foo equals hola, cat, quiz.sh, EOF, foo equals hello, if not, or if bang, square bracket, $sign, foo not equals hello, then touch if, fee, EOF, like this. Again, now we have the quotation marks around the EOF, so we do not interpret the $sign at the moment of creating the here document. This is a literal $sign and not a command to do command substitution. So we do not substitute this hola in down here. And when we run the quiz.sh file, this line right here will set the foo variable in the context of the script being run. And since we are actually referencing it down here in the file, we will do the substitution. Type ls down here, we can see that we currently only have the quiz.sh file. Type sh quiz.sh like this, and then our final answer is both if and quiz.sh. This whole expression here ends up evaluating to true, so we do create that file if right here. Any questions on problem number 4? Okay, problem number 5. Let's run that CD command. Touch, hello world, touch, hola mundo, touch, salve mundi, touch, quotation mark star. And so this, the purpose of this problem right here is to test your understanding of how the glob expansion relates to the quotation marks. So we have single quotes and we have double quotes. Oops, but I made a typo here. I typed an accident single quote. I let go of the shift key too soon, and so I'm still in the middle of this command up here. Again, anytime you're in the middle of the command, you don't want it to run, you can press Control-C. I'll press Control-C, and that will not run that command, so I will retype that command like this, and hit Enter, and then the touch star line 7. Recall again that when you have a glob command like this in single quotes, it is not going to get expanded. It will be treated as a literal star character like this. And so when I run the ls command like this, so this is not the answer, not line 8, but we'll do a debugging, inspecting why the line 8 will be how it is. Again, one useful tool when debugging shell commands that have these long pipelines inside of them is to break that pipeline into parts and inspect the leftmost parts before you run the entire thing. So before running line 8 all by itself, I will run just the leftmost part of this pipeline, ls by itself, and hit Enter. And when I do that, I can see that I have the Salve file right here, the Moonday file right here. I know these are two separate files because they are not contained in the quotation marks like this. Hola Mundo is one file by itself, Hello World is one file by itself, and the star is one file by itself as well. Another way to check exactly what is an individual file and what is not is I can do ls and pipe that to the cat command, and then each line corresponds to individual files. So we can verify that Hello World is one file and Moonday and Salve are also one file. And so now instead of piping that to cat, I pipe that to wc-l because I don't want to count, I am lazy, and I will force my computer slave to do that for me and hit Enter, and we get 5 is our final answer. Any questions about this problem? Problem number 5. Yes.
Touch glob ever do anything?
Question is, does touch glob, so like on line 7 like this, will this ever do anything? And the answer is, it depends on what you mean by anything. But literally what happened when I did a line 7 here with touch glob is that the glob expanded to all the files in the current folder, and then I touched all of those individual files. What touch does, if a file already exists, is it changes the timestamp of the file. So I type ls-l, and I can see the timestamp right here that the file was last accessed. And if I wanted to change the timestamp of all of those files to currently, then touch star like this. The star will expand to all of those files. I do ls-l, and we can see that that timestamp changed. In the context of a quiz problem like this, it's never going to ask you to write the timestamp of something, so it's not going to affect things, but it does have this sort of effect on the file system. One last thing about the touch star line 7 right here. The original question was, does touch glob ever do anything? And the answer is that in some contexts, it could do something related to the quiz. I'm going to do ls right here. Let's examine all the files in our folder. I'll do rm star to delete all the contents of this folder. Rm star like this, ls, and we can see there is nothing in this folder. And now if I do touch star, recall that the glob in the shell always, or if it cannot expand into something, if there are no files that match whatever the pattern is, star by itself will usually match something because you usually have files in there and star matches everything. But in this case, we have no files in here, so the touch star does not match anything. This glob character right here does not match anything. And so it does not expand to anything, and we pass the literal star character to the touch program, and now when I type ls, we do have a file in this folder. So if line 7 here had been the first line of the quiz problem, then it would have affected the outputs. Good question. Did that answer the question? Okay. Oliver, I saw your hand.
Yeah, so are lines 6 and 7 essentially the same?
Question is, are lines 6 and 7 essentially the same? Let's do I'm just going to add some more files in here for a second so that we have files. And now let's do echo star like this. And you can see that this glob right here, even though there are files that it would match up here, the glob in the double quotes does not expand. The glob never expands in any type of quotes, whether it is single quotes or double quotes. Glob only expands if it is by itself outside of quotes. So it's confusing because the single quotes prevent the $ substitution from happening, and the double quotes allow the $ substitution to happen, but the double quotes and single quotes behave the same with respect to the glob? Yes, great question. Miles.
So when you touch start, like binding indications, why doesn't hello world expand?
Great question, great question. So let's remove everything here, ls, and let's create this hello world like this. I type ls like this, and we see hello world. We have one file that is hello world. And so if I do something like echo star like this star expands into the hello world right here. And the question is, when I do touch star like this, should I think of this as being equivalent to touch hello world like this? You might think that's the case, where it just sort of copies and pastes the file name right here, and there's no quotation marks around here. There is a space right here, and so this seems like it should be creating two new files, hello and world, with that are separate files. But I'll hit enter right now, type ls, and you can see that that did not happen. That when the glob expands, because the glob is specific to file names, it's designed to always exactly match file names, and because there's no way to put like quotation marks around the glob and have it still expand, there would be no way for the glob to match hello world with a space inside of it if it behaved this way. So the glob does not behave this way. It does not literally copy and paste onto the command line in the same way that the $ expansion does, and instead it groups all those file names together as if they were in single quotes. So this is equivalent. The touch star here actually expands to something like this and does not expand to something like this. It's a great question, and lots of great questions about all these weird things about the shell, and like it does not seem consistent, does not seem intuitive about why this works the way it is. And yeah, once you start to get the sense of like the reasoning for things about the why things behave the way they do, like the star always is going to match files, and so we would never want it to behave this way. It makes sense why the designers made the decisions they did. But again, this shell program was invented in the 1970s. This is literally one of the first programming languages that ever existed. Nobody at the time realized that having some sort of consistency in how things work would be useful to people trying to learn how to program. And so there's a lot of those inconsistencies like that. And we're just stuck with it because of backwards compatibility reasons. But great questions. Evan. Question is on line 2 and 3. We have two different quotation marks, the single quote and the double quote. And why are they ending up behaving the same way? The answer is that the single quote and the double quote behave 100% the same. The only exception is with $signs, how $signs are interpreted. So if there was a $sign in the string over here, the single quotes would not interpret the $sign, and the double quotes would interpret the $sign. Otherwise, if there's no $signs, the single and double quotes always behave identically. Good question. Yes. Yeah, fantastic question. The question is on line 6 over here, what did it do? The answer is that for the purposes of the quiz, it did nothing. That because the glob behaves exactly the same in single quotes and double quotes, and by exactly the same, I mean it is just the literal asterisk star character. All line 6 did was update the timestamp, which is irrelevant for the purposes of the quiz. So line 6 effectively a no-op operation. No-op just meaning that it didn't do anything. No operation. Good question. All great questions. Problem 6. A short one, but sometimes short is bad because that means there are going to be confusing things going on. First line up here. And then the second line, the only line, for I in star, do echo $I. Done. And I'm not going to fully do the line 2 because, again, I'm going to use my good debugging practice to not run the entire pipeline at once to try to understand it, but do the leftmost thing first and then the right things later. So here I'm just going to run the for loop here, and we will inspect what's going on. I'm going to hit enter like this, and we see that we have a star in the output. Why is that? Well, when we have a for loop like this, the glob right here is going to behave as an actual glob operator because there are no quotation marks around this, so it will get expanded by the shell. In this case, the shell is looking at what files exist in the folder, and we talked about before that if we try to do the glob expansion and there are no files in the folder that can match your glob pattern, in this case there are no files, so no files can match the glob pattern, then we will just literally use the star character by itself. And so we have for I in star. This literally gets interpreted as the star character, and the I variable will have a star inside of it. We'll pass that over here to the echo command. The echo command right here, we will do the substitution right here with the star. Again, the star won't match any patterns, and so we literally pass star over to echo and print out the star right here. There's only one line in the output here, so pipe that to WC-L, and we get 1 as our answer. Any questions, problem 6? Problem 7, on to the evil problems. These problems are particularly hard problems, but I think they were basically just copied and pasted from your practice problems. So if you notice that, then they should have been easy problems. So make dir tist echo evil into -rf like this. So we create this file -rf right here, and then the question is, how is that going to interact with all of our other programs down here? Down here we'll do rm --/star like this. And again, if you have /star, this will expand. The glob still expands. It'll expand to -rf. So this is the same as rm --/rf. And whenever we have the // in front of something, the programs will know this is no longer a command line argument, but it is referring to a file because the dot refers to our current folder, and this is a file inside of our current folder. The -- over here is a GNU extension to the POSIX shell that says that anything after this is guaranteed to be a file and not a command line parameter. And so the -- over here and this // right here effectively do the same thing, and that's okay to have them both doing the same thing. It just means that this is a file over here and not a command line parameter. So I hit enter, and we get this error message down here saying we cannot remove /test. It's a directory. Again, this glob up here, I mentioned that it expands to the -rf, but it also expands to the test. And so the RM has both of those files passed to it. It will have successfully deleted this -rf, will not have deleted the test, so I run ls, and all we get is test as our output down here. Any questions about problem 7? Yes?
What's the difference between the double and
the question is, in output redirection, what, again, is the difference between the 2 greater than signs and the single greater than sign? 1 greater than sign by itself just means output redirection, where you delete the existing file if it exists, start over from scratch. And the 2 is appending, where you add on to whatever the existing file is. If the file doesn't exist, then you create it. In this case, the double greater than sign and the single greater than sign are exactly equivalent because this file over here did not exist before. Good question. One last problem, problem number 8. So once again, clear our folder, make dir ---- So here we using the GNU extension of the -- in front of here, so this -a does not get interpreted as a parameter, but literally as a file name. So we've now created this folder -a. Now I'll do echo evil into -a/evil like this and hit enter. And this expression over here says that this right here is a folder, and we'll put a file evil inside of the folder -a. And now when I do ls --star, what's going to happen is that this will expand. Again, the glob will expand to all of the files in the current folder, but not in subfolders. So this is equivalent to ls --a. This glob right here expands to this -a right here, but it does not expand to the evil over here. And I'll hit enter right now. This will be a little bit, I don't know, extra mind warping. Why do we get evil as the output over here? Because -a is a folder, and when you do ls of a folder, it shows you the contents of that folder. And so evil is the contents of the -a folder, and that's why we print out the word evil down here as our answer. A lot of things being tested here in problem 8, but this was literally just copied and pasted from the last problem of the quiz notes. So hopefully lots of people noticed that and got it correct because you'd already seen it before. Go ahead and total up all of your, yes, sorry, question, yes. Question is, here we have the output redirection, and I created the directory over here before doing the output redirection. Is that actually necessary? Echo, let's do a test, and you'll see that it is in fact necessary, that if you try to do it without the having created that directory, you'll get an error that the directory doesn't exist. So it was important that we had this make dir line. Because again, get your quizzes all passed up to me into that stack up there. Any other quizzes? Great. Okay, a couple of really quick announcements, and then technical stuff for today. So first announcement, our quiz next week will have this new set of notes on Git that the quiz will be about. Those notes are the title looks like this up here. The handout was up here on the front desk. If you haven't gotten one, feel free to come up and grab it. And so it'll have 4 problems from that notes packet, and then 4 that are review from anything that we've seen on the quiz today or the previous quiz. The review stuff will definitely focus. I will look at the quizzes, see what people missed, and it will focus on that stuff. We will also not be covering the Git notes in class. That's my expectation of you all, is that you either have enough background in Git that you don't need the any sort of review, or you're able to review that yourself to get comfortable with how Git works on the terminal. Again, if you don't feel fully comfortable on Git, then I recommend going through this CS46 tutorial again that will go through all the weird edge cases with Git. And there will be a lot of weird edge cases with the Git stuff. Any questions on the, I don't know, quiz for next week, what to expect? Okay. How many people here feel very confident with their Git abilities? Very small number? Okay, that's okay. You'll have an opportunity next week to show me how much you've learned over the course of the week about your Git preparations. Last announcement for today is that I mentioned a long time ago about the QCL. I don't think I ever actually showed you all the QCL's webpage, though, with their mentoring schedule over here. A couple people were asking about how to find that. Here is the link to the mentoring schedule, and if you come over here, you can see their open hours, 7 p.m. to 9 p.m. Most days of the week. And you'll notice that there is no explicit line here for anywhere for our class, big data. What was I going to say? Oh yeah, there are a handful of mentors who have taken big data before those, so there are people there still who can help you. If you're specifically looking for things related to Git review and how to use Git, anybody from the CS46 mentors would be a useful resource. Or again, one of my goals with the QCL for you all is to be able to use it as a space just to collaborate with each other. And in past semesters, there has always been people during these walk-in hours from Big Data working on things that you can go there and work with other people studying or working on labs or homeworks at the QCL. Any questions about the QCL? Yes.
You ever had like a GitHub issue specific for the class for like arranging when students are going to be in for walking hours?
Yeah, the question is doing something more formal about arranging collaboration times during the QCL hours up here. I have not posted one of those this semester. I would be very welcoming for one of you all if you wanted to try to coordinate times to just post an issue on GitHub to coordinate times about, oh, I'll be in the QCL this Tuesday. Anybody who wants to come work can come join me. That would be a very welcome thing to do. Good question. Any other questions about anything administrative? Okay. Actually, yeah, one last announcement. I know the lab room has been frustrating due to the poor internet. I've been talking to the registrar about getting us a different room that doesn't have computers in it, but actually has internet access. And they said they're working on it. And so by tomorrow, that won't be fixed, but hopefully at some point, it might be fixed. If not, we'll talk about some more workarounds for improving your internet SSH experience here in a little bit once we've talked about more things related to working in the terminal. Okay, today in class, we're in the topic 2 Docker folder. We are going to start talking about Docker. Before talking about it super technically, let's get a high-level overview of where we're going with Docker, why we're using it, and what Docker does. So as a reminder, in this class, the way the class is structured is that as we're going over new topics, I'm moving them out from this future folder into our main folder over here. And inside of this future folder, we can see at a high level what we'll be covering in the future in this class. And so we'll have 2 weeks, this week and next week, where we're going over Docker-related things. This week is Docker specifically. Next week is how Instagram uses Docker. You'll be actually recreating all of Instagram, all of their infrastructure next week. And then after that, we will be switching gears, not talking about the terminal and Docker and this sort of like operating system-ish, orchestrating computers material, and we'll be moving on to SQL, talking about SQL for the majority of the rest of the class. Why are we talking about Docker now? It's because we will need this material in order to be able to talk about all of this stuff related to SQL. Docker will be one of the tools that we'll be using in order to launch lots of databases, launch many, many different computers, and be able to run our SQL queries very fast and efficiently on all of those computers. So we'll have 2 more weeks of this operating system adjacent stuff before we get back into things that might feel more like data analysis and SQL. Okay, so Docker. Overview. First of all, Docker used basically everywhere in the modern CS world. There's this website, stackshare.io. I'll be referencing it as we learn all these different new technologies. But companies will advertise what technologies they use internally for many reasons. One of them is so that people who are experts in different technologies can know what companies use that technology and so where they might want to work. Docker is one of these technologies that is on this stackshare.io website, and I have it open. I don't have it open. Yes, I do have it open right here. Docker, there's a big list of 9,234 companies that are using Docker. Basically, every company that you've ever heard of is using Docker internally. So Pinterest, Shopify, Spotify, Twitter, all things that you've probably used or at least heard of before, all using Docker to manage their infrastructure. So these days, Docker is extremely popular, used everywhere to manage infrastructure. And so the question is, why? What is Docker doing? Why are people using it? So first, what is the problem that it's solving? It's that different computers can have different versions of libraries installed. And so code that works on one computer won't necessarily work on another computer. You might have experienced that before in previous CS classes, that you wrote something, you tried to share it with somebody else, and for various reasons, it doesn't work on that other person's computer. This thing called a Docker container lets you deploy your code, not just the code itself, but also along with all the dependencies of the code. So if you're using Python, you can deploy your code with like the actual version of Python and all of the libraries that you are using. And what that guarantees is that if your code works on any machine, it will work on every machine. So I don't know, a couple memes you can take a look at. Disadvantage of Docker is, as we will see, that it is a little bit hard to learn. There's a lot of different concepts that are working together on things. And because of the way they work together, you really can't fully understand any of the individual concepts until you understand everything all at once. So we will start today in class talking about a lot of those individual concepts. It's okay if it doesn't fully mesh together yet. Next week, by the end of next week, hopefully things will start meshing together a little bit more, understanding a little bit more. Okay, some useful references for this week. And then this basic command section we're going to be going over in class today, these basic commands and what they do. This is going to be effectively your cheat sheet. These are the things that I'm expecting you to be able to use proficiently on labs and homeworks and throughout the rest of this course, all of these commands here. There will be no quizzes related to Docker. Docker is complicated enough that this style of quiz that we've been doing, where I give you some commands and ask for the output, it's not feasible to do that with Docker. So you'll never be quizzed on Docker, but you will have many labs and homeworks related to Docker. So it's not going to be the case that you'll need to memorize any of this stuff, but you will just need to be able to use it when you encounter that situation on the projects. Any questions about anything before getting into the technical nitty-gritty? Okay. I'm going to come back over here to my terminal screen. I'm going to close that PDF window up top. Today I'm going to need two different terminals. So I assume everybody here, well, maybe I should rephrase that. Most programmers like to have hotkeys on their computer for programs that they use frequently. And I use the terminal, I don't know, more times a day than I can count. So that's the most popular hotkey I have to open up a new terminal. So I'm just opening up a new terminal up here on the top. You can see that it's currently connected to my laptop. So I need to connect over to the Lambda server. I'm going to press Control-R, type in my username for CS143 here, hit enter, type in my password, and now I have two connections over to the Lambda server. When working with Docker, it will be very convenient many times to have two terminal windows open up side by side and using them. One of the things that I've noticed walking around like the lab and just watching you all work is that many of you like to have two very tiny terminal windows opened like this that you switch between, back and forth between, or maybe like one of these is your Firefox window, and you are always switching back and forth between these things. You're also all using like tiny little laptop monitors, and you are still only using like, I don't know, a 3-inch by 4-inch terminal on your laptop monitor. So I see lots of people with their faces really close to their laptops, squinting to see everything, rather than making your terminal windows nice and large, filling up your screen, using all of your screen real estate effectively. When people talk about, like in interviews situations, talk about things that are like culture fit situations at companies, or would I like to actually work with people at this job, one of the things that they will be observing you as you're working is how you actually use your tools. And if people like see you doing things where you have very small windows, not using your screen real estate effectively, not using your tools effectively, then that's just a like, in the back of their mind, maybe for a lot of people very explicitly, will be thinking that this person doesn't really care about what they're doing because they're not using their tools effectively. So strongly recommend you use your screen real estate effectively on your computers. Okay, that was a big digression here. So let's get to Docker. Last time I talked about there was this instructions that I gave you all for installing Docker. And let's go over this a little bit. And actually, one more diversion here. So a couple people asked me how to pronounce this word up here, daemon with an A inside of it. It's still pronounced daemon. This is an archaic sort of spelling of the word daemon, but it has a very specific use in computer science, that any program that is running in the background of a computer is called a daemon, and it's always spelled this way with an A inside of it up front. It's still pronounced daemon though, and not daemon. So this is the Docker daemon that it's referring to. And then we had this instruction right here is our install instruction. If you thought about it, you could probably figure out what this instruction is doing. But the curl command downloads things from the internet. So we're downloading this file right here from the internet, and then we're piping it to this sh command. Sh, again, is our shell terminal, our shell program. And so we're just literally downloading some instructions and piping that into the shell, which evaluates those instructions. We can verify that by, again, breaking down our pipeline into multiple steps like that. See, this looks like a whole bunch of shell script things that we've been talking about in our quizzes, and then pipe that to sh like this, and it'll actually download those instructions and then run them. Very common way to install applications. You'll see people giving you instructions that look like this. It's a little bit dangerous of a thing to do, because if you do this, then you are trusting that whatever is in these shell instructions is actually going to do something beneficial to your system. You're giving whoever owns this file right here full, complete access to your computer to do whatever they want with it. So in this case, Docker's a reputable company, so I probably trust them to do that. But you might not want to do that for every random web page you see on the internet. Type ls down here. If I type Docker like this, then we can see that it's actually running something, giving me this this output down here, and so everything's worked successfully. Docker has been installed. If for whatever reason you don't have the installation didn't work for you, don't have Docker installed, then I have the office hours after class today that I can work with you to get that installed. There are a lot of different commands related to Docker that we will go over sort of one by one next. The first of those commands is docker run. And I'm going to type out a lot of stuff right here, and then we will talk about what it's all doing. So docker run -it, and then Alpine right here. And I'm going to hit enter. And looking at the output down here, we can see this first line here says, unable to find image Alpine locally. And so all of this output down here was relating to downloading this thing called Alpine. And the command down here, Alpine, is what we call is an example of a Docker image. The idea of a Docker image is that an image is like a snapshot of a computer. It has all of the things inside of it that you need to have a working computer running. So all of the programs that you might want to have inside of a computer, it has those in order to run them. It also has its own separate file system, its own, like anything that you might possibly need for a computer to run is contained inside this image. But the image is not the computer itself. The image is not actually running anything. The image is not the computer. The image is not running. Maybe you can think of the image sort of metaphorically. The image is sort of like just a hard drive, not the full computer. The other key word that we're going to see a lot is the idea of a container. A Docker container, you think of that, the metaphor is that it is like the computer that is actually running. And so for any one image, any image can have many containers, but any container has exactly one image. Any container has exactly one image. The image, again, is just like the outline of how you create the computer. You can create many computers based on that outline, and the container is the computer itself. After all this is ran, after it has downloaded this Alpine image, then it has put me inside of the Docker container. This run command runs this image here, creating the container and putting me inside of the container. You can see this prompt down here no longer looks like my standard Lambda server prompt because I'm no longer on the Lambda server. I am literally inside of a new computer that is totally unrelated to the Lambda server. If I type, for example, pwd right here, my present working directory is / right here. And if I type ls, we can see all the files in the / folder of my currently running container that I created with this command right here. I will verify that that is not the same as the information on the Lambda server by doing the same commands up here on the top terminal. The top terminal is still connected to the Lambda server directly. The bottom server or the bottom terminal connected to this new container somehow and not the Lambda server. Up here, I'll type cd / that takes me to the root folder. I'll type pwd. So I'm now currently in the root folder on the Lambda server. Down here, I'm in the root folder on this container. And if I type ls here, we can see that there's a whole bunch of different files on the Lambda server than there are here on the inside of this container. There's no relationship, even though I'm on the / the same location here in both of these terminals, there's no relationship between these two terminals and what's going on inside of one or the other. And in particular, once you're inside of a Docker container, there's no way to access the Lambda server anymore. You're stuck inside of the Docker container. Again, I'm not going to pause for questions at all today because there's a lot of things going on. Everybody should have a lot of questions in your mind about how all of this is working and exactly what it all means. But as we see more concepts, it will fill in some of those gaps. So down here, or in the top terminal, I'm going to run Docker PS like this. And now we can see that we have all of this information about all of the containers that are currently running. So Docker PS gives us information about containers, not information about images. Here we have this container ID. This is how we refer to this container down here. This is sort of like the name of this container down here that I created with this Docker run command. I'm going to leave my Docker container down here. I'll type exit like this to leave the Docker container and go back to the Lambda server. Up here on the top, I will rerun that Docker PS command, and now you can see this container ID no longer exists because the container is no longer running in any way. Press up arrow down here, recreate a new Docker container from this same Alpine image down here. Up here, rerun Docker PS, and now you can see there is a new container being ran, and the container ID is totally different. It's totally different because it's an entirely separate container, entirely separate computer that we're inside of, even though it has the same image over here, the same set of programs inside of it. I'm going to create a new terminal window now, so I have 3 terminals going on. Control-R, relog into the Lambda server. And I'm going to, in this 3rd terminal, run another docker run -it alpine right here. And now we have connected to two separate Alpine instances, 2 separate containers that are based on this Alpine image. By default, they both have the same contents inside of them at the beginning when I started the system. Down or up here on the top window now, I'm going to run docker ps, and now we can see that there are two different computers, 2 different containers that are running, both based off of this same Alpine image. Another way that I'll verify that these are 2 separate computers down here is I'm going to create a file in one of those computers and verify that it does not exist in the other computer. So over here, if I do echo test into test like this, type ls, we can see this test file has now been created inside of this container right here. And if I type ls down here, we can see that that test file right here does not exist in this container down here. So it's two separate systems being ran. The next command that we're going to take a look at is the exec command. So we've seen the run command. Docker run will create a totally new container. Sometimes, though, we want to not just create a new container, we want to run things on an existing container. So I'm going to pick one of these 2 containers up here, and I'm going to run a program on that container right there. So let's do, and we do that with the docker exec command. Docker exec, then the name of the container that I want to run it on. I'm not sure, well, let's see. I know that this one is going to correspond to this container in the middle because I have this created at column. The top container was created after the bottom container. I created this screen down here after the bottom screen. So this container should correspond, this container ID should correspond to this middle container right here. And then whatever I put after this is the command that is going to be run. Let's do a make dir example like this. I hit enter. There's no output of this exec command, but if I come down here and type ls, then we can see that there is now this folder example that has been created in this middle container right here, but that does not exist on this bottom container down here. One of the key properties of containers is that they're what we call ephemeral. Containers are ephemeral. And by ephemeral, we mean that any changes that you make to a container will disappear as soon as that container stops. These changes will disappear forever when that container stops. And so I'm going to exit both of these containers, exit and exit. Let's do docker ps again, verify that there are no containers running anymore. Down here, up arrow, rerun this docker run command, rerun this docker run command, and I type ls here, ls down here, and we can see that all of the files that I created in this middle container here, they no longer exist anymore. Docker run will always create your container from scratch. It will never sort of like save state between containers. So saving state from a container is not something that Docker is for. Is not something you should do. Not something you should do. So then how are containers actually useful? If we can't like save anything inside of a container, what makes it useful? The answer is that we create new images that contain the things that we already want to have inside of them, and then we will be able to deploy those images to other places. On your homework this week, that you will be creating a new image that has a website inside of it and deploying that website using Docker. Again, next week, you will be creating Docker images that sort of recreate all of the infrastructure for Instagram, and it will make it easy to sort of just bring up Instagram on the Lambda server or AWS or Google Cloud, wherever you want to bring up Instagram. How do we create these new images? In order to see this, I have an example file in our class repository for this week. I'm going to git clone our class repo. github.com/mike-is-bicky/cmc-csci143. Clone that, go inside of it in the topic 2 folder for this week. And there's this folder Docker example inside of the topic 2 folder. I'm going to go ahead, cd Docker example like that. And there's 2 files inside of here, Docker file and infinite.py. The Docker file is what defines the instructions about what goes on inside of an image. The Docker file is what defines an image. So Docker file defines an image. And I'm going to use Vim to open that Docker file. Maybe I'll close this intermediate window right here so we have more space. I'll use Vim to open this Docker file so we can see what it looks like. And the very first line here, this is like a base image that we're starting with. So there's 4 different images in this class that will be useful for us: Ubuntu, Debian, Alpine, and Python. Each one of these is, in Linux terms, what we call a different distribution of Linux. They just have different programs installed by default. Debian is what I use on my laptop. It's probably the most popular Linux distribution these days. Ubuntu is based off of Debian. Alpine is something that is specific for containers and only used inside of containers. So here, this is starting off of Debian, and then this run command these are just shell commands that end up getting run. The apt-get program in Debian is how you install new programs, and so these 2 lines right here are saying let's install Python 3. This copy command copies information from your current folder into the image, into the source of future containers that will be started, and then this command down here actually runs all of the is what happens when you run the Docker run command. It's a lot of stuff to take in. That's okay if you didn't fully take all that in here at this point, but we'll see an example of that next, how you actually use the Docker image. The command here, and actually before I type in the command, well, I'll just type in the command docker build dot like this. This builds that image. You do the docker build command, then the directory that contains the Docker file. So I'm currently in the folder with the Docker file, so it's docker build dot. This dot here refers to the current folder. See, there's a whole bunch of output of as these commands right here are getting run, a whole bunch of output, and then the final image will be created. This is the name of my image down here, this 2CE267. That is the name of my image. And so if I do docker run, and then this hash right here, that will actually run that image. And it's running now this infinite.py file. The infinite.py in Vim, infinite.py is just an infinite loop right here, so it's not doing anything. But if I run docker ps right here, I can see now that the container was created right here, and this is the image that container is based on. A lot of things really fast. We'll stop here for today. That'll be enough to prepare you for the lab and homework for this week. Again, I have office hours, so if you have questions about anything at all, but in particular about getting Docker installed, then I would be happy to help you with that. Yes, and let me stop the recording.